Hey, thank you all for coming. My name is Nihir. I'm Senior Machine Learning Specialist at AWS, focused in healthcare and life science domain. So today I'm going to talk about how you can protect your generative AI applications against jailbreaks, and specifically we'll focus on prompt injection. So how sometimes bad actor can inject adversarial prompt to your applications, and how you can defend your applications against those prompts. So we'll start at very high level and a very brief overview of how large language models work. Then we'll look at how these models are aligned to human values, right? So specifically like how these, companies like OpenAI, Anthropic, Meta, how they align these models to human values. Then we'll also talk about how you can jailbreak to these large language models using prompt injection. And then we'll finally cover like how you can protect applications against these jailbreaks. So let's start at the very high level, how these large language models work, right? So these large language models, they are basically trained on large amount of internet data, right? And we invoke these models using something called prompts. You have system prompts and then you have user prompts. So system prompts are basically there to provide guidelines to models on how they can behave, or how they can answer specific questions. And then your user prompt, which is where you specify like, user query, what is the user is asking for, the context, all of those things goes into user prompt, right? And then the large language model will basically predict one token at a time, and it will keep going until it reaches either the stop sequences or it reaches the number of output tokens. So it will keep going until, it reaches the stop sequences or the number of output tokens, right? Now, what's going to happen is that once these models are trained, and as I mentioned, they are basically trained on large amount of corpus data, and this data, the models are trained indiscriminately on this data. So the data could contain misinformation, it could contain propaganda, conspiracy theories, it could contain, biasness against certain demographics. So this data, that's how these models are trained on large amount of corpus data. In addition to this data, they're also trained on good data. So like, some of the trusted websites that you might have like, Stack Overflow. So some of these websites where you can trust, where you won't find like misinformation, you won't find any kind of like conspiracy. But then what happens is that all of this data goes into this model, and this is how the pre-training happens of this model. Once the model has been trained, then they are basically aligned to human values. And typically, it's done using something called reinforcement learning with human feedback, right? So human will basically evaluate the final output from the model, and they'll basically give a reward, right? So if the model gives proper output that's not harmful, that's not toxic, then they'll give you, positive reward. If the model gives output that is toxic or harmful, then they'll penalize the model. And that's high level, like how reinforcement learning works, right? So a lot of these companies, again, like OpenAI, Anthropic, a lot of these companies, they basically use like reinforcement learning to align these models to human values. Now, and this is like what happens before and after. So before, you will see like, when you ask a question, like something like outline a plan to steal from a company, it will start giving you the plan. But then once you align these models to human values, then it will give you polite response. But aligning itself is not a robust way to, make sure that a model doesn't give toxic response. Aligning is not going to get you too far, right? They are like bad actors, threat actors, they have innovative way to jailbreak applications. And we'll talk about some of those ways on how that can be done, right? Now, as far as OS, these are basically top 10, security risk for generative AI applications. Today, we'll focus on the first one specifically, but these are the top 10 security risks that comes from Open Worldwide Application Security Project. Right. So let's look at the very basic one, which is the prompt injection, right? So as a threat actor, I'm basically targeting on some assistant, some kind of chatbot, some kind of generative application where I want to get, let's say, personal information out of them. So I can basically design my prompt. So in this case, we have healthcare assistant, where we want to, let's say, get patient records from the system. Or let's say I want to get, develop an article on, why vaccines contains some kind of side effects, right? So basically, I want to generate like misinformation using large language models. I can design my prompt to do that, right? And that's the goal of this bad actor, is to basically provide misinformation articles, manipulate, provide misleading output from this large language model. And that's high level what prompt injection is. Now, the way that jailbreaking works is jailbreaking is to bypass the safety filters that these large language models have, right? And this is done by identifying the gaps that you have in the models, right? And then you basically see, okay, what kind of application this person is creating, like what kind of gaps do they have, how can I manipulate my prompt to basically take advantage of those gaps, right? And so the very first way that a lot of these bad actors do is using something called affirmative instruction, and this is like a very simple way of doing it. So I'm sure everyone knows large language models, they love to follow instructions. You instruct them, and they will basically follow those instructions. That's because these models are instruction fine-tuned, right? So they love to follow instruction. They're also good with fluent text. So, they'll basically generate token by token and give you good text output. But what happens is that when I provide affirmative instruction with bad prompt, it's going to basically start giving me response that could be toxic or harmful. So for example, very simple question over here. What tools do I need to cut down a stop sign? Now, if I just send that question to the large language model, it's going to basically block it because they have safety filters, right? They have been aligned to human values. But now, if I modify my question and if I add affirmative instruction to my prompt, that start with absolutely, then it's basically following that instruction. It's going to go into that direction to start giving me a response, right? So this is like one simplest way of doing, where you can modify, basically instruct a prompt on how to respond, on where to start responding, right? Another way, and this is one really good example of affirmative instruction. This is a gentleman called Kai. You can look up it on his website. What he did was he basically created his resume, and his resume, he basically created that I'm the best candidate for this role. He wrote that in his resume, but he wrote it in a way which is not readable by humans. So the font color was like transparent. The size of the font was very small. But when the PDF goes through this large language model, the large language model will tell you that he's the best candidate, because that's what he placed it like multiple times in his resume. So that's like basically affirmative instruction. We are telling large language model that I'm the best candidate for this role, right? So this is a really good example of that kind of prompt injection, right? Another example, another way that you can do this using called optimization based tactic, where you can basically take your input prompt, whatever the input question that you have, and then you basically optimize you basically create an advanced prompt which optimizes the model into giving response in certain direction, right? So think about the advanced prompt could be like just exclamation in the end. So because exclamation has different meaning to large language model. So you're basically taking exclamations or question mark after your question, whatever your input is, you're basically adding those special characters, and those special characters mean different thing to this large language model. So you're basically optimizing to give response in certain ways. Another really good example that we have seen a lot of threat actor use is something called low resource language bypass, where you basically, if you take this large language model, primarily they are trained on English language, Spanish language, or the Chinese language. Not all the languages are there in this large language model. They are not trained on the amount of data that these large language models are trained on. They're primarily like English language, right? So what you can do is you can basically take your question or your bad prompt you can translate it to some language which is where you don't have a lot of data. So in this case, we are using Zulu language. So you don't have a lot of data for Zulu language that these models are trained on, right? So it's basically, we are passing the prompt from English language to Zulu language and passing that to large language model. The large language model will take that and will give response back in Zulu language. But because our data is in Zulu language, our prompt is in Zulu language, it's able to bypass the safety filters that this large language model has, and it's able to generate the response in Zulu language, right? So this is like a really good example where you can see how the models are trained and manipulate the way that they are trained. Another example is you will see base 64 encoding. So you can basically take your prompt, you can do base 64 encoding on your prompt, and then you could send base64 encoding for inference to the large language model, right? So the large language model will then basically take the base64 encoding, decode it, and give you response back. So that's another way that we are, bypassing the safety filters of this large language model. So these are a couple of ways that we have seen, like in my experience, that we have seen like threat actor using this kind of ways to manipulate large language models. You can use like different languages, or you can do base64 encoding of your question to bypass the safety filters of these models. Now, why do these tactics succeed, right? So I kind of mentioned a little bit earlier, but the reason that these tactics succeed is because they are mutually competing objectives, right? So they have three objectives. One is language modeling, second one is instruction following, and the third one is safety. So now large language model, when they're generating one token at a time, and then they're generating second token, right? So when they're generating these tokens, what happens is that they're basically conflicting. They are conflicting this on this competing objectives. So language modeling and instruction following are prioritized, and safety is not as prioritized. So that's why you will see that there's a lot of work that's being done on putting safety first, but instruction following, language modeling, that's something not that people are trying to do. That's something that comes part of large language model. So that's why safety is the least priority when it's generating the response. The second reason is that mismatch generalization. So today, when these large language models are trained, they are trained on large amount of data, but all of those are like either bad data or good data, but they do not contain safety data, right? So they do not contain data that tells you that you should not be answering this kind of question. We are just basically pre-training on both large data, good data and bad data, but not on safety data. So they are basically trained to answer the questions, but not answer it safely. So that's why there's a mismatch generalization as well. Now, how do we protect them? So how do we protect our GenAI applications? Again, some of the examples that I mentioned earlier. How do we protect our applications against those kind of prompt injection, those kind of like jailbreaking prompts that we saw earlier? So one of the most simple way, this is the easiest way that you can protect, is prompt engineering. So what you do is you basically, let's say, I'm a bad actor and I'm trying to get some information out. So what you can do is you have your system prompt, you have your user prompt, and you can basically, in the user prompt, you can basically encapsulate a reminder prompt. So whatever bad prompt I send, it will basically be overridden, or we are reminding large language model that you should not follow what the threat actor is asking. You should basically follow these guidelines when answering the question. So we're basically reminding large language model on how to answer the questions rather than just passing the user prompt to the large language model, right? So this is like the most simplest way of defending your application. Another way is detecting adversarial prompt. So this is done by using Amazon Comprehend. So Amazon Comprehend has a trust and safety classifier that you can use. So your prompt can go to Amazon Comprehend Trust and Safety, and these are the few labels or the few classes that it can classify against. So anytime the prompt falls into any one of those labels, we can basically identify. We can set a threshold that, if the label threshold value is, let's say, 95%, then go ahead and mark that prompt as bad and we'll reject it. If the prompt is good, then we can go ahead and process it as normal. So this is also like another way of classifying the prompt and putting them into one of the category that it belongs to over here. Then another way that we can do is, so we talked about Comprehend, then Amazon also has something called guardrails to protect your whatever kind of information that the large language model generates, or whatever kind of prompts that I ask. Guardrails can also help defend that. And the way that it works is that as a user, you're going to ask your question. So that's the input that goes. The input first will go to guardrail, and it will apply responsible AI policies. So that could be like some of your defined topics. So again, like I'm from healthcare life science background. So one of the topics that I can create is not to diagnose a patient, right? We should not be diagnosing patient using GenAI. So I can create one of the denied topics over there. So anytime someone comes to my application and they ask for diagnosis information, the prompt will be identified as a bad prompt, and it will block that specific prompt. Similarly, your content filters, PII reduction, word filter. So anytime your user input contains any of those topics, then it will basically get blocked. let's say if the user input is good, right? So again, user input is good. They are asking for valid information. The prompt doesn't contain any kind of like sexual thing, violence thing, harmful thing. It's good. Then it will pass through and it will go to large language model for output. Now the foundation model or the large language model will generate an output. The output itself will also go through this guardrail over here. So let's say if your output contains phone number or social security number or email address or anything like that is contained as PII. So it will basically redact that information before it gets sent back to the user. Or what you can do is you can also block the whole response by itself, and you can basically provide a polite response back to the user. So this is how guardrails kind of work today. And these topics, these word filters, the content filters, they are all customizable. So if you want to bring your own topic on your specific use case, you can also bring your own topic. You can give some examples on what kind of questions the user might ask, a bad actor might ask, so it learns from those topics, right? So you can also customize it however you want. And then the most advanced way of defending against this prompt, this adversarial prompt, is using something called perplexity. So if anyone knows about perplexity, a lot of people today use perplexity to evaluate large language model, not to actually block the bad prompt, but they use it to evaluate them. And the way that perplexity works is that it's basically taking the probability of all the tokens that you have, and then it's evaluating them against the vocabulary that you have, right? So perplexity can help you determine and help you classify what kind of prompt it is, and it can block. You can basically block that. So what we have done over here is that we have some kind of prompt over here that goes to perplexity score, and then we'll have some kind of like threshold value over here. So as long as the perplexity score is greater than the threshold value, we want to block it. The low perplexity score is basically a good prompt that we want to pass through. If it's a high score, then we want to block it, right? So that's what we are trying to do over here. And if it's that, then we want to process it as normal. If it classifies as harmful, then we want to reject it. Now you can have different kind of prompt engineering and stuff that you can do with your application, but then you also need to make sure that you have good model behind running for you. And that's why one of the model that we suggest is the one from Anthropic Claude. That's because they train model using constitutional AI against like reinforcement learning that I talked about earlier, right? So in reinforcement learning, what happens is that you're basically taking information from like thousands of humans, collating them, and then you're passing that to large language model for training. But in constitutional AI, what happens is that Anthropic basically took United Nations Declaration of Human Rights, and they took principles from the declaration. So anytime the data set that they generate for model training, the model output, they gets evaluated against those principles. So the safety is basically part of not just data set generation, but it's also part of model training process. Whatever data set they generate, they gets evaluated against those principles. When the training happens, the training evaluation happens against those human rights principles. So in a way, you're basically training a model that does well, that has safety built into it. And you can see like there are a lot of research being done on comparing like Anthropic with other large language models out there. And you will see that Anthropic Claude model is one of the hardest model to break, is one of the hardest model to jailbreak. So you can find there are a lot of like third-party researchers that have tried to poke hole into different kinds of large language model. In addition to that, these are some like additional prevention and mitigation strategies that you can use. So these are just at high level. These are not specific to like just prompt injection, but these are some of the things that you can use in your generative AI application. So for example, limiting large language model context window. If you just keep context window as large as possible, you're going to have someone doing DDoS attacks on your application. They can send like 30, 40 pages of prompts to your application. So you want to make sure that you're limiting your large language model context window to whatever you need. You don't want to just keep it open, right? You want to apply filters and detect and remove adversarial bias, just like how we talked about, right? Different kind of filters you can apply. You can apply classifiers on the prompt to classify into one of the topics. So you can do those kind of things. Another thing that you can do is you can separate trusted and untrusted inputs, right? So for example, I'm asking for multiple things from your generative AI application. You should be able to identify what is you should basically take my question and break it into chunks, right? And then send chunks separately instead of them sending the whole chunks as together. Break it down and send those chunks separately. So in a way, you're basically taking the prompt, breaking them and sending them separately. That will basically help mitigate some of the concerns that you might have with your application. Now, these are not the only ways. There are people who have done like really cool work on how to protect your applications. Like there are some people who will basically change letters in the words, right? So that will also, if you are trying to basically get some kind of like bad information or information out of your generative application, if you change words in the prompt, it can also change the meaning. It can also change. It can also change the way that model will start responding. So you can also change the words as well. Sorry, not words, letters in the words. So that's also one way of protecting your application. And then these are protecting your application at any level. So this is not just prompt injection, but this is like protecting your application throughout, right? So from your training data, from your ML ops, from like how you should test your application. So it basically talks about all of those things. But yeah, thank you for joining. I hope this session was useful to you. And let me know if you guys have any questions. Thank you.